Hello everyone, welcome back to another video of this section of my channel entitled The Devil is in the Details, where I explain little nuances which can make your electronic project an absolutely success or a completely nightmare. On this occasion I'm going to talk about Labview and Arduino Uno, and how to control the internal voltage reference of the analog to digital converter. I will do it with the driver Linx, but if you want to push your limit, you can create your own firmware, as I did in a previous video available on this channel. The link of that video is in the description of this one. If you are watching this video, it's maybe because you are not able to control in Labview the change of this voltage reference, or because your measurement doesn't have the expected resolution, or simply because you have tried the Arduino Uno after connecting any kind of voltage in the AREF pin. Trying to cover all these circumstances, I have divided this video in 3 parts. Apart from this introduction, which is section 1, in section 2 I'm going to cover all these hardware details that you have to understand about the analog to digital converter. In section 3 I'm going to deal with the little nuances that you have to understand in Labview in order to program correctly the change or to manage the change of this voltage. Without further ado, let's start it. It is relevant to mention that I have installed in my computer the driver Linx, and also I have uploaded into the board the firmware of this software. If you don't know how to do it, I have an excellent video, to show you how to do it. The link is available in the description of this video. Right, second part of this video, which is related to the hardware. The hardware is the Arduino Uno, it's here, and also I have connected this cable to the pin that I referred before, that is AREF. Okay, so next step is to check with the X schematic, what connection we have inside. Focusing on the schematic, the pin that I showed you before is represented here. The Arduino board is represented by this firmware, and the internal one is going to be the microcontroller that you have inside the board. So the line, goes inside. What you are going to have after the arrow is going to be the analog to digital converter. The line can be connected to this voltage, which is VCC. Theoretically, is going to be 5 volt. And by default, when you connect the Arduino Uno, that one is going to be closed. But also inside, you have 1.1 volt. Which is very useful, especially when you have a voltage to measure that is going to be less than 1.1 volt. In that way, you are going to increase the resolution of your measurements almost 5 times. So if you want to connect here, the thing that you have to do, is to send that command in the setup, of your program. In that way, all the line is going to have a value of 1.1. But imagine that you want to measure something that goes from 0 to 3.3. In that case, that is not going to be a solution. The ideal solution is going to set here a voltage of 3.3. All right, so if you use this line, also you have to send a special command that is going to be analog reference external. And you are going to connect, as I told you before, here your voltage. But this configuration, if you want to use it like that, you have to take some precautions. Otherwise, you can damage the Arduino. To show you what is the problem that you can have, I need another schematic to explain that case. The risky situation will take place once we connect 0.5 volt to the pin AREF of the Arduino Uno. Straightforward. Directly. And we don't wait to charge your program where you are going to define that the analog reference is going to be the external one. Or simply you forgot to send that. In that case, this MOSFET is going to be closed and the current will flow without any kind of limit through this line. In that case, probably the thing that you are going to do is to damage the MOSFET. If you burn the MOSFET, so no longer you are going to have here 5 volt. But there is a solution to prevent that problem. As you can imagine, the idea is adding an external resistor in order to prevent any kind of current to go through. The current is going to happen if you forget any of the things that I commented before, but the current is going to be limited to a few milliamps, which are not going to represent any kind of problem for this MOSFET. Important thing, you have now to take into account that this reference voltage is not going to be any longer equal to that. Because of that, I changed the name of this one, okay? So AREF is going to be defined, this voltage, by the voltage divider created by R1 and R2. So AREF is going to be AREF2, the external one, okay? And now you have a ratio here that is R2, R1 plus R2. Okay, if you are wondering what is the reason of this resistor, the idea is to add here a capacitor and create a low pass filter, and in that way you are going to filter any kind of noise that you have there. Okay, the important thing is to take into account, okay, this change in the voltage and also adding a resistor. By the way, before closing this topic, I would like to mention, because I have seen a lot of things in the laboratory, that the voltage here, the maximum value that you can have is 5 volt and the minimum should be 0 volt. The voltage there should be in that range. Let me give you this last tip related to the hardware of the analog to digital converter of the Arduino Uno, which is not connected to the AREF pin or the external voltage reference. It's more connected to the analog input, and how to measure when you want to measure several channels. If we take a look at the board, okay, I have represent here the Arduino board, external framework, okay. This rectangle, the internal one, okay, is going to represent the microcontroller. The first thing that you are going to find is a multiplexer, and after this multiplexer, what you are going to have is the analog to digital converter. Something that you have to keep in mind all the time is the inputs of this analog to digital converter are not differential. That means that all the channels are going to share the same ground. Okay, so to exemplify what is the problem, I have here this circuit. And believe me that I have vivid memories from this circuit, because it represents a connection or a circuit that one friend of mine used it. And he wanted to know what was the performance of this battery, and also he wanted to measure the current through voltage across this resistor, some resistance that you know what it is, and also he wanted to measure what was the voltage at the terminal of the load. Okay, and the problem is with this configuration, my friend burned, okay, the Arduino Uno. To know, okay, what is the problem, let's go to think that we are an electron, okay, that is going to start from here, from the positive terminal, okay, of the battery. The electron arrives at this fork, and now he has two choices: to go through the stand resistance or taking this green line. The problem is once he arrives here, all right, so the input resistance is going to be infinite, and there isn't any kind of leak of current through there, so he's forced to cross the sun resistance, and he's going to be in the other end. Okay, again, if he tried to go to the red line, it's going to happen the same. Okay, so here you are going to have infinite resistance, no leak of current. So the electron basically has two options: go through the blue line now, or keep on going through the load resistance. Nothing to say that the electron is going to avoid any kind of way that represents a higher resistance. So look what happened with the blue line. So the electron, which want to arrive to the negative terminal of a battery, It's going to do that thing without finding any kind of resistance. All right, and now voila, okay, it's able to arrive there, avoiding crossing through that resistor. So what is the thing that is going to happen? That you have a lot of current that flow through this line, because the only resistance that you have is a sun resistance, and the sun resistance should be a small resistance, small enough to avoid any kind of in order not to disturb the operation point of the circuit that you want to measure. So this peak of current, especially provided by a battery, is huge, enough to burn, okay, all the tracks, all the board, and especially the internal that you have in the microcontroller. So what is the lesson, okay, that we can extract from that? So if you have to use several channels of the analog to digital converter, remember to connect the grounds of these channels, okay, at the same point of the circuit that where you want to measure, okay? Try to do that at all cost. If you need to move these grounds and connect it in different parts, okay, make a double check. Otherwise, you can end up, okay, as my friend here, and the result is that you are going to burn the Arduino Uno. Third part of this video, which is related to Labview. First of all, let me explain you what is the experimental setup that we have here. So this is the Arduino Uno, which is connected through the USB port, and then here the thing that I'm measuring with my multimeter, I'm measuring the voltage at the AREF pin, refer of course to the ground pin of the Arduino Uno. Then the channel 0 I have connected to ground. This channel is going to be measured by the Labview application. To measure from this pin is not the important thing, so I'm going to focus on the voltage reference of the analog to digital converter. My target now is to build an application where I have the full control over the voltage reference of the Arduino Uno. In that application, I have to be able to modify the voltage reference of the analog to digital converter while the program is running. The thing that I want to see is if I have any kind of improvement in the resolution of the measurement that I'm going to take when I change from 5 to 1.1. Also, I would like to see how the display of my multimeter is going to change when I send the correct command. First of all, let's go take a look, okay, at the examples which comes with Linx. Through there, there is one which is very interesting, which is analog set voltage reference. If we click here and see what we have under the hood, okay, we have this while loop, and in this part, okay, there is a very interesting BI, which is this one, which is going to set the voltage reference of the Arduino Uno. Anyway, this program, okay, is very simple, because this change is going to happen only at the beginning, but once you are inside the while loop, no matter what, okay, you are going to change that this change is not going to have any repercussion, okay, inside the while loop. So my idea is to build something better and something that you can change, okay, on the spot while the program is running. All right. So let's go. Okay, so this is the application that I have built, and I don't want to extend too much in the explanation of it. You have the link to download it in the description of this video. Let's go to take a look what we have under the hood, and here we have our while loop. And before all this part, what I'm going to do is to initialize the board and also to define by this one what is going to be the voltage reference. Although I'm going to change, okay, with this case that I have here. That case is going to refresh the value, okay, of the voltage reference once you click here. Parameters that are going to be needed is analog reference, which is the numeric value of the voltage that you have at the AREF pin, and also that this control that you have here that can change from default, internal and external. Because I want to, if I click here default, I want to have 5 here. If I have internal, I want to have 1.1. To do so, that is the reason why you have to include this OK button. But also you need some kind of resource to manipulate all that things without sending the final value to the Arduino Uno. Because of that, I need some kind of intermediate variables that you have here. Okay, you can do it also with some event extract. Okay, but I prefer to do it like that. So after changing that voltage reference, the thing that I'm going to do, what I'm going to do is to measure the channel 0, okay, of the analog to digital converter. All right, so that is going to repeat over and over with, here I have a delay, half a second, that it's more than enough, okay? So let's run the program and see how that works. Right, the moment that everybody is waiting for when I have to run the program, Control R, and the first case is default, okay, 5 volt here, and in my displays 5.04. Wonderful. So I'm going to change into the internal, okay, and look how after changing internal you have here 1.1. But the intermediate values didn't change. They are going to change once I click here. And after doing that, the voltage, voila, 1.1, the internal voltage. Wonderful. The one which left is external. When it is external, you have to provide that voltage. Let's say that this is 2, but remember that we had 2 MOSFET transistors inside the analog to digital converter. Now, after sending external, these 2 MOSFET transistors are going to be open, okay? So if both are open, the voltage that we are going to have, okay, in that AREF is going to be 0, as we have, because the Arduino is waiting for these 2 volts. Finally, I would like to comment, okay, that if I go back to default, I have here a wonderful voltage. That is because I'm using a USB hub, which has external voltage supply. And this is the best way in order to improve the accuracy of your measurements, okay, and be sure that you are going to have 5 volts. Okay guys, so that's all from my part. I hope that you have found this video interesting, and also I hope to see you soon. Till next time, bye bye.